Hello students, this is Dr. Rajesh and I am with you with my new video lecture on the topic numerical problems on projectiles. So first video lecture was on the problem shared by my student, and this is an important problem that I am sharing with you. Before I share the problem with you, I would like to discuss an important concept with you. Concept is, like we have a projectile like this we have. Here you see the projectile is projected from here with velocity of projection u and with an angle, say this angle is alpha, and the same projectile is projected from this point O, making an angle beta and with the same velocity. You have to keep this in mind that velocity in both the cases is same. Then the horizontal range that is described in both the cases is same. So we will try to establish that in that case what is the relation between alpha and beta. If such a case is there when two different angles of projection and the particle is projected with the same velocity of projection with two different angle of projection, the horizontal range remains the same, then what is the relation between alpha and beta? We know that relation of horizontal range is equal to u square sine 2 alpha upon g, and here is also u square sine 2 beta by g. Horizontal range is same in both the cases, so may I write it something like that? It will be this thing. Fine, it will be this thing. So what we'll do, we'll be cancelling this one, so we are left with sine 2 alpha is equal to sine 2 beta. Now we use the formula, this one, if sine theta is equal to sine alpha, then theta is equal to n pi, general solution is equal to, you already know this one. Fine, so in this case it will be 2 alpha n pi plus minus 1 raised to the power n 2 beta. So dividing throughout by 2. Fine, and n is an integer quantity, so take n is equal to 1. This implies that alpha is equal to pi by 2 and minus 1 raised to the power 1 is minus 1 beta. This implies that alpha plus beta is equal to pi by 2. So this is the relation between alpha and beta. So you must keep it in mind that this is the relation between alpha and beta, so as to produce the same horizontal range when projected with the same velocity of projection. So this was an important relation that I have to share with you and discuss with you. So now I will be coming to the problem, and this problem is very important from the examination point of view. This is exercise question that I have taken, and the statement of the problem is given by: a particle is projected so as to have a range r on the horizontal plane through the point of projection. Okay, so horizontal range is r. Fine, you can write horizontal range. Done. If alpha beta are the possible angles of projection and t1 and t2 the corresponding times of light, show that t1 and t2 are times of light and alpha and beta are angles of projection. So see, let me draw. This is the axis, okay, and this is the projectile, and this is the horizontal range given, and this is the angle of projection alpha. Fine. Now second angle of projection is, this is projected with velocity u, and this is this one, and this angle is beta. So we could use the earlier case that we have discussed now just now, that in this case alpha plus beta should be equal to pi by 2 provided the velocity of both the projectile should be same. But in this problem you look, nowhere it is mentioned that both the projectile have same velocities, so we could not say that this will be also having velocity u. So this could have different velocity, and say this is velocity v. So if I say in this case there is no relation between alpha and beta, if u and v would have been equal, then we could say that there is relation alpha plus beta is equal to pi by 2. So now this thing is not valid. So r is equal to horizontal range, and say we will say that these velocities are u and v. Okay, horizontal range, what is the formula for horizontal range? You know, u square by g you have to write, and you also have to write for alpha it is u, okay, and for beta it is v. Fine, it is very clearly mentioned. For alpha it is u, for beta it is v. U and v are the velocity of projection, and alpha beta are angle of projection respectively, you could write here. Now next is time of flight is given, and we know that t1, we can't just interfere with the symbols, whatever is given we have to take, we even can't take capital T1. So this T1 you know is equal to 2u sine alpha by g, and T2 is time of flight, say this time of flight to travel from O to A, and this is time of flight T2. This will be 2v sine beta by g, and what we are going to take, we are going to give this equation as number 1, this as number 2. Now from these two equalities we will see we have, can we say that this equation I want to name, and I have to name this equation as, I'm going to name this equation as R-stick. This is named as equation R-stick. So from equation R-stick we have u square by g sine 2 alpha is equal to v square by g sine 2 beta. G to g will cancel out. This implies that u square by v square is equal to sine 2 beta by sine 2 alpha. So this will be 2 sine beta cos beta divided by 2 sine alpha cos alpha. 2 to 2 will cancel out. This will be sine beta cos beta sine alpha cos beta, and what you will name it as equation number 3. Now take the ratio, because you look at the problem, we are given that T1 and T2. If we are anyhow able to find T1 by T2, then component and dividend could give this one. So firstly we will try to find what is T1 by T2. Dividing equation 1 by 2 we get, so what we'll get, T1 by T2 is equal to 2u sine alpha by g divided by 2v sine beta by g, and g to g will cancel out, 2 to 2 will cancel out. This will be u sine alpha v sine beta. This implies that T1 square, squaring both sides, now that we could do u square by v square sine square alpha sine square beta. So take it now, that implies t1 square by t2 square. From equation number 3, what is the value of u square by v square? It will be sine beta cos beta sine alpha cos alpha. So I am going to put the value sine beta cos beta sine alpha cos alpha dot sine square alpha sine square beta right here using equation 3. So this sine to sine will cancel, this sine will cancel, so we are left with cos beta sine alpha cos alpha sine beta. So this could be written as sine alpha cos beta sine beta cos alpha. This implies that t1 square by t2 square is equal to sine alpha cos beta sine beta cos alpha. Now next, applying componendo and dividendo. Applying componendo and dividendo on both sides. What it will be? It will be t1 plus t2 square, t1 minus t2 square sine alpha cos beta plus sine beta cos alpha divided by sine alpha cos beta sine beta cos alpha. Now sine, it is a alpha plus beta, a plus b sine, and this is sine alpha minus beta. This is t1 square plus t2 square, t1 square minus t2 square. Now this is equal to, taking the reciprocal, this is equal to sine alpha minus beta sine alpha plus beta, and this was required to prove. So in this lecture we have proved the required relation, and this question is very important from the examination point of view. So this is all I have from this lecture, and if you have liked the lecture, please like, subscribe, share and comment. Your comments in the comment section are always welcomed, valued and appreciated. This is Dr. Rajesh saying you goodbye. Thank you very much. Thank you for watching. Take care.